All right, so this is the second water lecture, and we already saw this slide before. I just wanted to point this out because one of the things that water will do is when we look at a solution, we're often looking at whether it's acidic or basic. So that is our pH scale. So I do want you to know definitions of these two. In acid and a base, what I need you to know is an acid is actually what they call a hydrogen ion donor, and a base is what we call a hydrogen ion acceptor. So acids will actually put out H pluses, and bases will actually accept them. So that's really by the definition. So here on the left is a pH scale. I want you to know that scale. 7 is neutral, pure water and human blood. Anything with a pH lower than 7 is considered to be acidic. So anywhere from 7 to 0 is acidic, and the lower the number, the more acidic it is. And then the opposite is anything greater than 7 is a base, and the higher the number, all the way up to 14, is the stronger bases. So here you can see something like lemon juice, gastric juice, which is your stomach acid, is about a pH of 2. And then if you look at a strong base, something like household bleach and ammonia are strong bases, which is why we use those as disinfectants, because they actually kill living things or living cells. And so that's kind of what we want you to look at. The other thing I want you to realize is when you look at a 7 to a 6, how much stronger this stuff is. So when you go from 7 to 6, I want you to realize that this is not just one time stronger. This is actually what we call a logarithmic scale. And when you go from 7 to 6, that's an increase of 10. And then you go from 7 to 5, that's 10 and 10, which is actually 100. So I want you to realize how much more acidic it would be as you move up, or how more basic it would be as you move down. So just to give you an idea, the Richter scale, which is being phased out now, but that earthquake scale is actually a logarithmic scale. So if you think about it, you lived in California long enough, you probably lived through an earthquake, and when you get used to them, if that's possible, we always talk about what is it, and you can see we have tremors probably daily. And as long as they're under 2, we really don't feel them. And then once they start getting into the 3 range, that's when you hear people at school would talk about them. Hey, did you feel that this morning? So we don't worry too much. Something like a 6 or a 7 is huge. And that's where we had like the Whittier quake and the North Ridge quake. Those where they did major destruction. The North Ridge quake, I was working at the LA Zoo, and I got a phone call. Actually, it was my day off. And they said, hey, we need you to come in. And I said, no. And it wasn't because I was scared. I told them, I can't get there. Freeways were shut down. It would have took me all day just to get there. I was in a specialized area. They needed somebody to feed them. So somebody from the other show was there, called me, and we talked about, how to feed, what to feed the guys we had. So, but anyway, so here's kind of the statements I just want you to realize. So, we talk about big ones, and we'll probably talk about this in the Zoom session next week. So, but again, the Richter scale. The other thing I want to talk about is acid precipitation. The old term was acid rain, but it's not necessarily just rain. It's any moisture that comes down, rain, snow, sleet, fog, anything that has a pH of 5.6 or lower is considered to be acid precipitation. So here you have a house, you think, oh, hey, this is cool. I have a nice view of the lake. But if you look closely, you can see these trees right here are being damaged, and they're being damaged because of acid precipitation. The acid is actually killing that. And you're thinking, well, what the hell do I care? Because I can't afford a house up there. And if I could, I could see, I have a good view. But there are other plants that don't do well, and you might think of crops. We know that acidic soils will diminish how much our crops grow. So that's talking food for the world. What causes acid precipitation? Most of that is done by fossil fuels. The burning of fossil fuels put sulfates, CO2 in the air, high up in the atmosphere, mixes with moisture, and it comes back in the form as acid precipitation. And so here you can see this is a statue that was on a building, and then after 20 years, this is what acid precipitation has done. And some of you are like, I don't give a shit about art. Well, maybe that's true. But a lot of our great monuments, the Sphinx and the pyramids in Egypt, and the ones down in Mexico, are being eroded. Actually, Mount Rushmore, the four heads, they actually wash that on a regular basis because that is also being eaten away. And so, and again, you might not care about art, but I will tell you, think about your car, your tires, your windshield wipers. How often do you have to change those? That rubber is being eaten by acid precipitation. And the ocean. The ocean has, what we have found out is carbon dioxide causes climate change. We'll talk about that later. One of the things they didn't realize is it'd actually be going up even more. But the ocean is actually taking a lot of that CO2 in. That was realized just a few years ago. But the problem with that is that now the ocean is becoming acidic. Here you can see 20% of marine life is actually coral. Most coral has a calcium carbonate skeleton that they make. And two things are happening. Warmer weather is actually causing calcium to be less calcium in the water per liter, which causes a problem, so not as much is available. And then the other problem is the acid is actually eating away at the coral skeletons, and we are losing our barrier reefs. So you're all going to die. So just leave it on a happy note. One last topic. Your stomach acid is, and we'll talk about this a little bit more, but your stomach acid is about 2.0. The rest of your digestive system really is around neutral, around 7. I think it's a little bit less than that, maybe 6.8, somewhere in there. Well, what happens is sometimes you'll have upset stomach. And so what that is that acid reflux is when it starts to come up into your esophagus, or the acid in your stomach might, just drop below that 1.5, 1, which will cause all kinds of problems. And one way to alleviate that is to use a buffer. And what a buffer does is actually regulates pH, not necessarily at 7. In your stomach, it would be at 2, but it tries to maintain it. And we have systems in our body to do that. So what happens in your system, if your stomach gets, the acid starts to get low, your body will start releasing bases to kind of bring that number back in check. And the same, if it gets too basic, acids will be added. Well, this is another way of doing that. These are bases. This is basically, if you've taken Tums or you've taken Mylanta or some kind of antacid, what you realize is they're kind of chalky, and they're chalky because of they are a base, and they are trying to raise the pH of your digestive system to give you comfort. All right, so that will be that for this lecture.